Those of you who don't know the British Museum, that's the entrance to the British Museum. And this was a few years ago when quite a few of the volunteers, some are guides, some are volunteer at hands-on desks, and others volunteer to help with parties and that sort of thing, all gathered together and had our photograph taken outside the front. You can see me there. If you go right, almost in the centre, right here, that's me just there with the jacket and the white shirt showing underneath, just to prove that I was one of those guides. So the idea of time, when Isabelle sort of discussed this with me, I thought it was quite an interesting thing at the moment. I thought I'd start with a few quotes. One of my favourite novels is The Hitchhiker's Guide to the Galaxy by Douglas Adams. And at one point he says, time is an illusion. Lunchtime doubly so. So I don't know if it's lunchtime for anyone joining this. It's not for me here, so let's hope that's okay. He also elaborated on this by saying, reason notwithstanding, the universe continues unabated. Its history is terribly long and awfully difficult to understand, even in its simplest moments, which are, roughly speaking, the beginning and the end. The wave harmonic theory of historical perception, in its simplest form, states that history is an illusion caused by the passage of time, but time is an illusion caused by the passage of history. Typical Douglas Adams humour there. From a more serious point of view, there's a Professor John D. Norton at the Centre for Philosophy and Science at the University of Pittsburgh, who puts it slightly differently. He says, a common belief among philosophers of physics is that the passage of time of ordinary experience is merely an illusion. The idea is seductive since it explains away the awkward fact that our best physical theories of space and time have yet to capture this passage. I urge that we should resist the idea. So he doesn't believe that time is an illusion. St. Augustine of Hippo, writing around about 400 AD, wrote, what then is time? If no one asks me, I know. If I wish to explain it to one that asketh, I know not. And I think he's quite right there. When you're trying to explain it, it becomes far more difficult than we actually know. And going to good old Wikipedia, I thought, let's see what they had to say. Time is the indefinite continued progress of existence and events that occur in an apparently irreversible succession from the past through the present and into the future. I'm not sure if that's terribly helpful, but anyway, we'll carry on. It seems to become more important during lockdown, as Isabelle was saying. In the UK, we were told before lockdown that if we all washed our hands for 20 seconds, and seconds a measure of time, we'd be safe. To do this, we had to sing happy birthdays twice to ourselves to measure 20 seconds, whether it was our birthday or whether or not we were happy. We were told that symptoms might not appear for a week, and again, the week's a measure of time. If they might, then we had to self-isolate for 2 weeks. Many people who ventured on holiday had to go into quarantine for 2 weeks when they came back, and whole towns were locked down for a whole month. All these are measures of time, but they're artificial measures of time. I'll come into that in a moment. Some firms furloughed their staff for so many months. Schools had to go off for so many months and start back on a certain point. And these are all artificial measures that the government was working to. We've all stopped to reflect on our lives as well during this time. But what we perhaps don't realise is that all measurements, most of the measurements of time are artificial. The only natural measurements of time are the year, the month, and the day, and even those we have to alter. The day is the time it takes for the Earth to spin around its axis once. The month, the natural month, is the time it takes for the moon to wax and wane, which is roughly 29.5 days, which is not a very useful measure. The year is the time it takes the Earth to travel around the sun, which is roughly 12 2/5 months, or 365.25 days. Again, not terribly useful. The week is a completely human invention, as are the hour, the minute, and the second. We have to tweak the month so that it fits in with our ideas, because it's so difficult to work with this idea of 29.5 days. The two traditional methods for measuring time, recording time. We use the calendar for periods longer than the day, for the week, the month, and the year, and we use clocks for periods shorter than the day, hours, minutes, and seconds. There's quite strong evidence to suggest that the month and the year were recorded even in the Stone Age. And I've got a couple of images here from the Stone Age. This is a picture in the British Museum's picture collection by John Constable of Stonehenge. And it's thought that Stonehenge was some sort of clock. At midwinter, the sun appears to rise above a particular stone, although modern Druids prefer to celebrate it when it appears on the other side.
Oh, of course you do. Please do.
Right. And even in Wiltshire in southwest England, it's quite slightly warmer in the summer than it is in the winter, so you can understand why the modern Druids prefer the summer solstice to the winter solstice.
And Stonehenge, actually, I was there in October. Stonehenge is much smaller than we think. It's actually almost disappointing.
Yes, it's. I mean, I've got the next slide is actually a photo of me there with my mother and my sister in 1964. The days when you could actually walk round the stones, which was quite nice. But yes, right. It seems bigger when you're actually up close to the stones. You sort of get an idea of the scale there. But yes, it is. When you have to look at it from a distance, it does seem much smaller than it is.
Right. Sorry, I
no, it's right. No, that's fine. I found this in an old photo album. I thought it was quite interesting to see back in 1964. But the changes in the season, even to early man, they must have been aware how time progresses over the year, changes the seasons, and also notice the position of the sun when it rises and when it sets over time. That it seems to move along the horizon at different points. And this is how they measured their year, worked out how a year worked and how the months worked, and realized that it got warmer in the summer and colder in the winter, and these were connected to the position of the sun as well. So it's a very early idea, this idea of being able to measure time passing as the seasons change. And also the amount of daylight. Of course, the lower the sun is, the less daylight there is to carry out the normal tasks that you have, such as farming and hunting and that sort of thing. They must have also noticed that as the seasons changed, animals migrated, animals that they needed to hunt, or things like salmon coming to spawn, or birds behaving. But in some places, of course, there are very seasonal, spectacular events like the inundation of the Nile, the River Nile in Egypt, or monsoon season in India, or hurricane season in America, and so on. So it's quite these sort of events must have been aware to early man, seeing the passing of time. But how did they calculate it? The month, say, is a very strange idea, and most ancient civilizations seem to have realized that you could have 13 months in the year with just a few extra days over, but people don't like the number 13. It's not easy to work with mathematically. So most ancient civilizations had 12 months of varying length of days, just as we do today. And they sometimes fitted in extra days at the end of the year to add on. In America, the Mayan civilization had 18 months of 20 days each, and then 5 days at the end of the year to try and fit in. So it's a very difficult thing for early people to get a handle on. In 45 BC, Julius Caesar standardized the lengths of months and how to calculate the months. And one of the months was changed its name to honor him. So Quintilis became July after Julius Caesar. And his great nephew Augustus changed the following month to August after his name instead of Sextilis. The Julian calendar became the standard in Western Europe for about 1600 years, until it started to get really out of step with the year, because they didn't make allowances for the fact that there are only 365 and a quarter days in the year. And it was Pope Clement XIII in 1582 who got rid of 10 days to make this fit, the year fit better into the seasons. And this became known as the Gregorian calendar, Well, the whole of the Catholic world accepted that, but the Protestants were a bit slow off the mark, and this caused some problems. When William of Orange became King of England, King William III in 1688, his native Netherlands had already started to use the Gregorian calendar, but the English were still using the Julian calendar. So they were 10 days apart. It must have made setting up meetings for him very difficult, depending on whether he was in Britain or in the Netherlands. You can't imagine having those two calendars working together. And in fact, it wasn't until 1752 that the English government accepted the Gregorian calendar, by which time they were 11 days out with the rest of Europe. And when they got rid of these 11 days, there were riots in England, people shouting, "Give us back our 11 days." They thought the government had made their life 11 days shorter, which is rather sad, but of course the government ignored them. In Russia, the Gregorian calendar wasn't accepted until 1918, after the Russian Revolution. So it meant, in fact, that the October Revolution in 1917 actually took place on the 7th of November. And you get that sort of strange quirk in history. The week that we accept today is a completely artificial invention by the Babylonians. About 5,000 years ago, they invented that. They seemed to like the idea of having a weekly worship, but also they had 7 days of the week after the 7 astronomical bodies that they could see in the sky. So it's the sun, the moon, the 5 main planets: Mars, Venus, Jupiter, Saturn, and Mercury. And we still use those names for the days of the week in most Western countries today, sometimes with a slightly German spin on it. And the week really does regulate our lives to a large extent. We often do things weekly, and it's all thanks to the Babylonians 5,000 years ago. When I was growing up, schools, shops were closed on a Sunday, so you knew that was part of the week. Monday was always wash day, Wednesday was always sports day at school, and Saturday night was always bath night. And if there's anything else that you do weekly, it's those Babylonians that you've got to thank for it. It's quite a legacy of ancient Babylon that we still follow the weekly routine for ourselves. And when it comes to these shorter measurements of time under the day, we come to the horologist, we come to the clockmaking. And again, it's ancient civilizations who first had the idea of trying to measure the passage of time. And one of the first ways of doing this was looking at the sun crossing the sky. And the idea of a sundial seems to have started again in ancient Egypt about 3,500 years ago. And they used a T-square, which was orientated to the east until dawn, and then turned around to orientate it to the west for the rest of the day. And they divided the daylight hours into 12, and then the nighttime hours into 12. So the hours were of unequal lengths depending on the time of year and where you were. So you might have longer hours during the day and shorter hours during the night, which is quite an interesting concept. In fact, in Japan, they carried on doing that right until 1873. So when a lot of the earliest Jesuit missionaries gave them clocks as presents, they were totally useless in Japan, because a clock always tells you equal lengths of hours, and in Japan they didn't have equal lengths of hours, so they were just a sort of a show thing, which is quite interesting. It was the Egyptians also had the idea of dividing the day into 12 at night and 12 during the day. Not quite sure why they used the number 12. 12 is quite a useful number in mathematics. It divides up quite easily. And they also used the 3, 4, 5 triangle for getting a square. If you remember your Pythagoras theorem from school, the 3, 4, 5 triangle is a triangle with a right angle. The idea of using base 60, so because we have 60 minutes and 60 seconds, again comes from those Babylonians. And it's about 4,000 years ago that the Babylonians first started using base 60. And they used it for dividing a circle into 360 degrees. And then I say we've adapted it for 60 minutes and 60 seconds. During the French Revolution, they were obsessed with the decimalization, and they actually tried to change the clock into decimals. They had 100 seconds in a minute, 100 minutes in an hour and 10 hours in the day, which is a very difficult system to work out. So instead of 86,400 seconds in a day, you had 100,000 seconds in the day. Thankfully, Napoleon abolished this and went back to the system that everybody else was used to. So I talked about sundials. These are some of the early sundials we've got in the British Museum. One on the left is an Egyptian, part of an Egyptian one, made from for a priest called Ahmose, about 200 BC. It's largely missing, but with the inscription on there does tell us what it's for. And the one on the right is a Greek sundial, although it's got the gnomon missing, which was the stick which was poked out here. You can see where the shadow of the sun was measured amongst over on the base of the sundial. We can't date this exactly, but sometime sort of between 480 and 31 BC.
Bill,
yes.
The Greeks had two concepts of time, didn't they? They had the concept of the quantity of the time, which is, I think, the chronos, but they also had the concept of doing something at the right time, didn't they?
Yes, that's right. Yes, a number of ancient civilizations seem to have had that same sort of concept. Yes, Chronos was the god of time and also the god of old age. So yes, Chronos, time in that sense, is where we get the word chronology and chronometer from Chronos. Yes, but yes, as you say, they had the sort of separate idea of the time to do something. Yes,
right.
Yeah,
the opportune moment to do something.
Absolutely, that's
which
right.
I think is just so relevant right now.
Yes,
we're always wondering, when is it the right time to do the right thing? What is the right thing to do? If nothing else, for traveling or for meeting up or for hugging, and which obviously we can't do now, but we're all wondering, when is it going to be the right time to do that?
Yes, and it's also something that the governments are trying to regulate for us, that we can't just decide for ourselves. So it makes it even worse, more difficult. There's just a few more sundials here from the museum's collection. There's a Roman one on the left, made from rather nice marble with these rather fun lion faces and feet at the bottom. And on the right, this is a chalice actually used by a church. But it's got the sundial inside. You can see the divisions for the hours of the day. And telling the time became extremely important for the church to work out what time various offices should be held. And so something like this could be used by a priest traveling around to make sure he got the right time to do particular services. And this one comes from Germany, made in 1554. This is rather a sweet little one. It's a compendium, an astronomical compendium. So it's got a sundial in it. It's got star charts, a calendar. This device on the right here is called an astrolabe, and I'll talk about astrolabes in a moment. And inscriptions, one of the inscriptions on it says, "Recognize that the shadows divide the time into hours and that time is fleeting. A human life is like the way of a shadow." So it's almost like poetry written on this little compendium. This is another slightly later one from the 18th century, polyhedral sundial. So you've got different places you can have the gnomon pointing to the sun and telling the time when you're traveling around as well. And you always get these traveling sundials with a compass in them, because you need to know which way is north, so you can orientate yourself in the right way. And this one is another portable sundial from the Byzantine world, from the 5th, 6th centuries AD. And you can see the markings on it. And this is a sort of early version of the astrolabe. Sundials obviously are not very used for telling the time at night, but the astrolabe could be used for telling the time at night. Astrolabe, it comes from the word for star, measure of the stars. And you could work out your latitude using your astrolabe during the daytime, and then at night you could point it to particular stars and work out the time at night as well, because particularly for religious purposes, you need to know the time during the night, not just during the day. This is an astrolabe in the British Museum collection from 1236, made in Cairo by Abd al-Karim. And it's one of those spectacular ones. It's a large, very large asteroid, quite heavy to lift. I'd never been allowed to lift it, but I imagine it's quite heavy to lift. And the Arab world became the great inventors of these sort of things during the early Middle Ages. It's the Greeks who had invented the astrolabe back in about 200 BC. And then a lot of their knowledge and science was passed on to the Arabs when they took over that part of Eastern Europe. It was calculated by the 10th century, the astrolabe could carry out 1,000 different calculations used for 1,000 different things. But by this stage, by 1236, it was also a work of art in its own right. And I've got a couple of close-ups here. You can see all these little pointers that pointed to particular stars. You've got birds and fish and monkeys and various things to help the astronomer to work out the exact position of the stars and for the time of day and for the latitude that he was standing at. There's a little close-up of the monkey. Seems curious today that in the Islamic world, you're not supposed to show these sort of things, but in the 13th century, they were not quite so particular.
Is this object at the British Museum?
This is in the British Museum, yes. This is, again, one that I include sometimes on the tour when I do the tour of the clocks, because it's such a beautiful thing. We use it on one of the other tours. It's in the new Islamic galleries, which only opened a couple of years ago. So,
and how big is it?
It's probably about a meter across. It's really quite a large.
Oh wow!
Perhaps a bit less than that. I can't remember the exact size, but it's it's sort of larger than a football. That sort of size. Yeah. Right. Other methods of measuring time were, one of the other early methods was a water clock. By letting water drip through a hole in a measured basin, you could actually measure the passing of time. And this is very important for Egyptian religion. Again, their priests had to carry out certain rituals and certain sacrifices and so on at certain times of the day. So the earliest one we know of is from the tomb of Pharaoh Amenhotep I, who died around about 1505 BC. Again, this is in the British Museum, this particular statue of Amenhotep I. And the name we give these water clocks is the clepsydra. And again, this is a broken part of a clepsydra from ancient Egypt from about 320 BC. And you can see on the outside how it's important for religion. You've got the pharaoh giving offerings to various gods. This is the pharaoh here giving offerings to another god here, with the goddess Sekhmet behind him. And on the inside of it, you've got these measurements which show the passing of the hours during the night. These work very well as long as you've got somebody to keep replenishing the water. And if somebody forgets to fill the water up, then of course you've lost your measurement of time. You have to come back and recalibrate it. These are also known in the Babylonian world. This is a Babylonian tablet in the museum which records the use of a water clock in about 2000 BC, so about 4,000 years ago, and a slightly later one from about 600 BC. I don't read Babylonian cuneiform, I'm afraid, so I can't tell you exactly what that says, but there's only 12 people in Britain who can read cuneiform tablets, so I'm not one of them. Another type of clock was the candle clock, and again this seems to be a fairly early invention, perhaps not as early as the water clock, but the idea of a candle burning down, you can put measures on the side of it as it goes down. If you make all your candles the same size and the same type of wax, beeswax, you can measure the passing of time quite accurately. This is one of an Arabic manuscript, which is actually in the Smithsonian Museum in Washington, an Arab scientist called Ismail al-Jazari, who made a movable candle clock. As the candle burnt down, got lighter, it went up, and you actually had a marker that actually tell you the hours of the day. So quite a brilliant use of the candle clock. And the candle clock became one of the standard forms of measuring time in monasteries in Western Europe. King Alfred the Great is supposed to have invented a type of candle clock, which was used in English monasteries for hundreds of years. And only monasteries and kings could actually afford the candle clock because beeswax was enormously expensive. And all those early monasteries had beehives so they could have the wax for making their candles. And a byproduct of that was that they could have honey, which again was a very rare product, and they could make things like mead out of it, which is something they could sell, which is why so many early monasteries became very wealthy with some of these byproducts. But the ultimate goal was to make a mechanical clock. And the earliest ones we know about, again, were in China. There was a mercury-powered clock as early as the 11th century. But in the West, it was this chap, Richard of Wallingford, who was abbot of St Albans Abbey, who invented a mechanical clock in about 1330. And this manuscript comes from the British Library, showing him pointing to his clock. Now, it doesn't survive, but some people have tried to recreate it. And you can see it doesn't really look much like a clock to us today, because it didn't have a face. It had a sort of backplate based on the astrolabe with pointers on it. So he was developing this on from the astrolabe itself with various gears and mechanisms. And it had a verge escapement, these weights that sort of swung backwards and forwards to regulate the clock. You notice it's got a bell as well, because the more sophisticated you got, you could actually have a bell chiming the hours, so the monks knew when it was time to go for a particular service. And that's where we get the word clock from the Latin clocker or the French cloche, meaning a bell. So that's where, technically, if a modern clock doesn't have a bell, doesn't strike the time, it's called a timepiece rather than a clock. And some antique dealers are very pedantic about this. And if you say you've got a clock for sale, and they say, does it strike the time? So it's not a clock, it's a timepiece. So you have to be a bit careful sometimes with some of these people. Right, during the Renaissance, the shift moved from the church to astronomers mainly, who started to work out new sophistications for clocks. And in a moment, I'll take you up the stairs of the British Museum to show you some of the clocks in the museum collection. I just said about how the clock developed in the 16th and 17th and 18th century. The astronomer who first invented the minute hand was called Jost Bürgi. He was a Swiss mechanic and astronomer, went to work in Germany. He was a friend of one of the greatest astronomers of all time, Johannes Kepler. And between them, they wanted to make the clock so accurate they could actually measure the passing of a star over the lens of their telescope in minutes, see how many minutes it took to actually pass over the lens of their telescope. And he managed to do this. He was known as the second Archimedes because he was so brilliant. He also invented the remontoire, which is part of all clocks from that point, which gave you a secondary power source. These early clocks were powered by either weights falling or springs turning. And as the weight fell, the time was not regular. It went slightly different speeds. And if a spring unwinding, again, it goes at slightly different speeds. And by inventing the remontoire, which gives you a secondary power source, that could be powered up by the first power source. And then it winds up to a small extent, then one unwinds again and then winds up again. So it keeps it more regular. And his clocks were so accurate, they stayed correct to a minute a day, which was pretty spectacular for the end of the 16th century. The most important development after that was the invention of the pendulum clock by Christian Huygens in Holland in 1656, which he combined with an oscillating balance spring. And he was inspired by Galileo's work about 70 years earlier. Galileo had done some work on the pendulum, and Huygens realized this could be used for regulating the clock. You didn't just have to rely on the gravity pulling the weights down or the spring unwinding. He also invented a pocket watch, quite interesting. And one of the things he was interested in was trying to solve the problem of longitude. This is the period when people were going all around the world in ships, and you could work out your latitude fairly easily using an astrolabe or a backstaff or a quadrant or a sextant. But working out your longitude is virtually impossible unless you have a very accurate clock. And he thought his wonderful pendulum clock would be the way of solving this. But as soon as they test it out, of course, the pendulum doesn't do very well on a moving ship. It goes all over the place, so complete failure. But he had the right idea. So that's just the background to timekeeping. We're now going to do the tour of some of the clocks in the museum. Was there any other comments before we go on to this? Isabelle, you want to say anything?
I think that's good. I don't see any question in the chat box. If you,
Right.
as always, if you have any questions, everybody put them in the chat box. Because it's not a lot of us, we can also give the microphone, to whoever wants to ask a question. But just put the question in the chat box.
Right. So the British Museum has about 7,000 clocks, watches, and other scientific instruments, and it's the national collection of clocks and watches. And to get there, when the museum's open, you come into the main entrance, which I showed you in my first slide, and you turn left up this staircase, go to the top of the stairs, and when you get here, you just turn to the right and you move over to this door over here. And the first clock you see is this spectacular clock, which is one of the museum's greatest masterpieces. It dates from 1589 and was made by a man called Isaac Harbrecht in Strasbourg. And it's a close-up of it here. He was commissioned to make a clock for Strasbourg Cathedral. And on the right there, you've got the cathedral clock, which is still there in the cathedral today. That was commissioned in 1574. The old clock in Strasbourg Cathedral was about 100 years old, and it was breaking down. They got fed up with it breaking, so they wanted a new clock. And they asked the professor of mathematics at the university, a man called Conrad Dasipodius, to design a new clock for them. And then when they asked all the local clockmakers, none of them could actually make it. So they called in Isaac and his brother Josias from Switzerland, and it was Isaac who actually made this clock. And it was so successful that he made some copies of it to sell to ordinary people. Now, the original clock in Strasbourg is about 40 feet high, and the copies are only about 5 feet high, so they're much smaller than the original. And although they're based on this of the left-hand tower here, which wasn't actually part of the mechanism, you can see the cockerel on the top there. It includes all the various mechanics of the main clock. You see the different dials here for telling you the calendar, the days of the year, the phases of the moon, the position of the sun. You've got the hours and minute and quarter hours on here. They haven't worked out using minutes yet. And then you've got these wonderful processions at the top. I've got some close-ups of some of these in a moment. And it's beautifully decorated as well with panels representing the things like faith, hope, and charity. So here we are. This is Isaac Harbrecht, became very famous, very rich for this. And this is a paper by Conrad Dasipodius, this great mathematician who worked out this clock. There we have the cockerel from the original clock. It's rather poor condition these days. So he's in the museum in Strasbourg. And there's one other of these smaller versions surviving, which is in Copenhagen. That's the one on the right. But it doesn't work as well as the one in the British Museum. There we have another view of one in the British Museum with justice, fortitude, and wisdom on the left, and the mechanics of the interior on the right.
Sorry, can you just...
Yes, sorry.
It looks like I was going to ask details about these justice, fortitude, and hope, but it looks like you're going to go into it.
I'm going to say a little bit about it. Yes, I mean these are the virtues, the three theological virtues of faith, hope, and charity are on one side. On the other side, you've got the worldly virtues of wisdom, justice, and fortitude, and those are just so one of hope and one of fortitude. And then on the back of the clock, you've actually got the three fates. So this clock was actually meant to be seen in the round. You could actually look all the way around it and see this spectacular thing. And it was meant to be a work of art as much as it was a timekeeping piece. The original clock in Strasbourg was there for the cathedral to work out the times of day for services and so on. But these copies were sort of for private consumption.
And is this all engraved or painted?
All engraved, yes. These are engraved on the metal. That's sort of gilt copper. The metal, which has been engraved with these wonderful images. That's just two examples. I haven't got the others.
So that would have been that would have involved some silversmith. So I mean, there's the
Yes.
invention of the clock. That's one thing, but then
Yeah.
they make
No, that's right. I mean, there would have been a guild in Strasbourg, just as in most major cities, that which would have been involved in making the rest of this clock. So Isaac Harbrecht would have just done the mechanics of the clock, and then others would have carried out the specifications for the design and the decoration of the clock. I don't think we know. They didn't sign their work usually in those days. Some people try to guess the designer of these, but it's quite difficult to pin it down to any particular craftsman of the period.
Right.
This is the dial at the bottom, which has the days, the saints' days, calculation of Easter. You can see the sun and the moon and the phases of the moon in the center here. We've got representations of the 4 great empires of the past on the 4 corners. Assyria, Persia, Greece and Rome. Again, you see here an overall passing of time that people are interested in. Lots of saints' days, so rather than just the days of the week, the days of the year, you've got lots of saints' days, so they know when it's a particular saint whose anniversary it is. And that's the interior of the clock, showing you the mechanics of the clock. And it's also musical. It plays a tune. It plays a tune actually written by Martin Luther, who is quite a surprise considering this was made for a Catholic cathedral, that Martin Luther should have been chosen to have his tune involved in it. And I'll mention this in a moment about who this is actually made for, this version of it. You can see these 4 processions on the left, on the front of the clock. The days of the week were shown as gods, just as they were in the ancient world. And then you've got Madonna and Child with angels, and you've got the 4 ages of man striking the quarter hours, and then you've got a little death up here, which I'll show you some details of these in a moment. There's the Madonna and Child with angels processing around, and they sort of bow in front of her before they go carrying on round. And this is when the Martin Luther's Lord's Prayer hymn tune is played when this goes round. Now this does still work, so if you get to the museum you can actually get to hear this playing. It's been restored a number of times. And at the top 2, as you can see, some quotes here from the Bible. O death, I will be thy plagues. O grave, I will be thy destruction, on the left from Hosea. And the wages of sin is death, on the right from the book of Romans. And here we've got the 4 ages of man striking the quarters. And the old man, it was actually one of the Magi. Originally, the Madonna and Child had the 3 Magi processing round her. They got lost at some point in his lifetime, and only one of them survives, and he's put on here. There you can see the back of him and the child striking the first quarter. And again, when you get up close, you can see lots of little details all engraved with this. It's a fantastic work of art in its own right. And then right at the top, you've got originally Christ used to come and strike the daylight hours, and death struck the nighttime hours. Now death strikes all the hours, and Christ just sort of comes out of his little cubby hole and wobbles a bit and goes back again. So it's had a difficult life, this clock. It's thought, it was originally said it was made for the Pope Sixtus the Fifth, I think it was, but it seems unlikely that he would have wanted a tune by Martin Luther. So we now think it was probably made for the Elector Palatine, who was a Protestant, and during the 30 Years' War, his palace was ransacked by the Catholics, and they took various booty back to Rome, and that's how it became associated with the Pope. And it was bought in Rome in 1829 and then sold to the King of the Netherlands, William I, King of the Netherlands. And it then went into private hands and was on show in London in 1848, when it was offered to the British Museum for £400. The British Museum turned it down in 1848, said it was too expensive. It was then bought by a collector called Charles Octavius Swinnerton Morgan, one of the great clock collectors of the 19th century, who was a friend of one of the curators of the museum, Augustus Franks. And he offered it again to the museum for £100, but again the museum turned it down. When Morgan died in 1888, he left it to the museum in his will, so the museum got it for free, having turned it down twice. So there's a moral in there somewhere. When the museum got it, it was broken. It didn't work at all. And one of the curators at the museum, Mr. Batten, repaired it in 1922 to get it working again. And it's been repaired a couple of times since, in 1957 and 1989. And if you want to know what it sounds like and looks like and can't get to the museum, you can look at this video on YouTube. If you wanted to make a note of that, or I can send you the link. I'll send it Isabelle the link, and you can get it from.
Yes, that would be great. If you can please send me the link. There's a comment here from Kathy, who says that it looks like a much more elegant precursor to the glockenspiel clock in Munich, in Germany. And I've never been to Munich, so.
No, I don't know that one. I mean, there are a number of these in Germany. Originally, I say a lot of these clocks, spectacular clocks, were made for cathedrals, inside cathedrals, but during the Reformation, a lot of them were made for town halls and various towns. There's one in Hameln in Germany as well, which I've seen, which is a sort of version of this. And the sort of civic pride that these towns wanted to show off that they could afford one of these things, because it was enormously expensive to produce something like this. And there are some still going. So I guess the one in Munich is the same. It's one of those sort of Reformation ones that's still working. And there are various other places. I think there's one in Prague, which has one like this, huge one on the town hall. There's one at Fortnum and Mason's, which is a much later one and not quite spectacular, but it's a similar sort of thing with characters coming out and striking the bells. Mm-hmm. Right, if you leave that behind you and go in through the first room into room 39 in the museum, you can see this ship in front of you. And at first glance, you think, what's a ship doing in the clock gallery? And we're going to be looking at one or two of the other clocks around here as well. And this ship is actually also a clock. It was made by Hans Schlotheim of Augsburg in about 1585. And again, this came from the collection of Octavius Morgan, and there's a picture of Octavius Morgan in the museum. And you can't, at this angle, see where the clock is, but the clock face is actually, I'll get the point, it's just down here, just about make out a little bit of it. And you can see the men in the crow's nest have got hammers. Those are the bells to strike the hours and the quarters. And there you see a close up. This is the emperor, the Holy Roman Emperor, and he's got a procession going round him of the 7 electors. The emperor was elected by other rulers in Germany, and there's the clock face with the imperial eagles over it. And there's another close up of the clock face and the emperor with his procession going round him. Now, the original of this clock was made by Schlotheim in 1581 for the Emperor Rudolph II in Vienna, and it was made in silver, and it was so spectacular that other people wanted a copy of it. So again, if you were very rich, you could commission Schlotheim to make you a copy, and we think this particular copy was made for the Elector of Saxony in Dresden. And again, we don't know what happened to it for a long time. Eventually got into Morgan's collection, and he gave it to the British Museum in his will. The interior is quite amazing. You can see a little bit here, the bellows and the characters on it. This figure is quite an interesting one. He came up for auction in 1983 at, I think it was Sotheby's, and was bought by a private collector called Rainer Zietz. The museum tried to get it because it's obviously one of the original figures from this clock, this ship. But when he realized he'd been bidding against the museum, he gave it to the museum for nothing. So again, it's a case of having lost something but gained it for nothing. It's quite good. Now, looking at this interior, you can see it's not just a clock. That's not just clockwork. These are bellows in here, and there's lots of very fancy gear work going on. And what this nef, as it's called, which is a centerpiece of a table, actually did was it sailed. You wound up the clockwork, and the ship started at one end of the table, sailed along, stopped in the middle of the table. At that point, the bellows started playing, a little organ started playing a tune. There was actually a drum skin with little drumsticks in it, tapping away the rhythm. There were some trumpeters on board who seemed to be blowing their trumpets. And that's when the electors processed around the emperor. And when they'd finished, the ship carried on down to the end of the table, and at the end of the table it stopped again, and the cannon at the end fired, and then all the other cannons around the outside fired as well. So it was quite a spectacular thing. Then presumably everybody cheered and clapped, and then you got on with your dinner. But a wonderful centerpiece. But if you look inside, it looks a bit like Meccano. It's sort of scratch built and all hidden by the beauty of the ship itself. So it's not the most sophisticated mechanism, and that's why it didn't work when the museum first got it, and they've never been able to repair it successfully since. It was a sort of secondary version. The one in Vienna, I say, was silver, and this one was made from copper with gilding on it. And that's the other side, showing again these rather strange mechanics inside. A bit of a close-up of the gearing. This is the one in Vienna, which does still survive. And you can see it's rather more spectacular. You've got these wonderful sails, painted sails on it. And this one they have repaired. And again, there's another website here on their YouTube site, which I'll give Isabelle so she can pass on. And you can actually see it sailing down the floor, the table, and with the drummers playing, the pipers piping, and at the very end of it, the cannons all fire. So you can see what the British Museum one used to do, but doesn't do anymore, sadly. And there's a third one of these. Schlotheim made several of these, and the third one is in Écuan. I'm not sure if I pronounced that correctly. The Musée de la Renaissance in Paris, and that's what this one looks like. There's a close-up of it. And you can see this has got far more people on board. You can see the trumpeters and the drummers and other little men on it, the emperor over here. And inside it's completely empty. There's none of the mechanics surviving at all on that one, so it doesn't work at all, but still quite a spectacular piece of work. It's thought this one was actually made for the Ottoman Emperor in Constantinople, and at some point ended up in India and was bought by a collector who then took it to Paris. This has actually got 8 electors on it, so it must have been a late work. By 1623, there were 8 electors for the emperors. That's how that one got there. Right, so if we turn to the left after having looked at the ship, you can see this clock in the case over here, which is the next one I want to talk about briefly. And it's made by this man, Thomas Tompion, who's one of the greatest English clockmakers ever. And it's called the Mostyn Tompion. It's a spectacular clock. And it was made for William III of England, who had it in his bedroom at Kensington Palace. This is his one of his other rooms, his picture gallery in Kensington Palace, which has got a wind dial on it, a famous wind dial. You can see his map here. It's got a wind showing whether the wind was coming from France. He's always worried about an invasion from the French. He's very interested in mechanical things. But this clock was made for him by Thomas Tompion in 1689, using the pendulum invented by Christian Huygens 30-odd years before. And one of the most amazing things about it is the inside of it, is that it only needs to be wound up once and it will go for a whole year. The bell strikes 56,940 times over the year, and during that time it keeps amazingly accurate time. It's the most spectacular piece of engineering. So the total opposite of the Schlotheim ship. But again, with this spectacular engraving on it, you can see a close-up of the engraving, Thomas Tompion's name on it, hidden from view. And it shows you the days of the week. Sorry, Isabelle.
These clockmakers, was it a from father to son tradition?
Yes, very often. Yes, I mean, you had to be a member of the Clockmakers Guild, and it was a sort of closed shop. So you needed to either know somebody, be apprenticed to somebody. Usually the son would be apprenticed to one of the other clockmakers and learn his trade there, and then perhaps go back to work for his father and take over the business after his father died. But yes, it was a sort of fairly closed-knit community, just like the silversmiths and the goldsmiths and all the other main guilds in London, and I guess Amsterdam and other cities as well have the same idea.
Does the guild still exist in the UK?
I don't know the answer to that. I guess it does, but I don't actually know. Most of these guilds do still survive, but whether they are quite so closed as they used to be, I think you don't have to be a member of the guild, the Clockmakers Guild, to be able to make clocks anymore. especially as clocks aren't made in the same way quite they were in the past,
Right.
maybe quartz and so on. But there's a close-up of the days of the week. So again, you see the ancient gods, Roman gods being used. There's Mars for Tuesday, with Diana for Monday on the right, and Mercury for Wednesday on the left there.
Is it painted metal?
No, that's engraved again as well. This is all engraved on the metalwork.
It's engraved on the metal.
Yes.
But the metal is white. Is it just a photo, or is it?
It's. I think it's using the technique of niello, which is a sort of silver, darkened silver, to engrave it. There we can. Even we didn't know who it belonged to. You can tell it's William III's coat of arms, because he's got his coats of his arms as King of England around the outside, and in the middle of the Lion of Nassau, as he was a Prince of Nassau, as ruler of the Netherlands. And some rather wonderful silver work with the Lion of England, the Unicorn of Scotland, unicorn a little bit bent, poor old horn, and the Rose of England, and the Thistle of Scotland again, sagging a bit over the last 300 years. But again, the clock still goes, and we have Britannia on the top. The reason it's called the Mostyn Tompion was because when William III died, he left it to the gentleman of the bedchamber, the Earl of Romney, who left it to his nephew, the Earl of Leicester, and it went through his family to the Lords Mostyn. And the Lords Mostyn had a wonderful ritual they went through on Grand National Day, when the race called Grand National was held once a year in Britain. All the staff in their stately home put a bet on the horses, and they all wound the clock, and each one had one wind of the key for the clock, because it only had to be wound once a year. So they did it on that Grand National Day, and one of them won money on the horse, and the others all had a fun time. They had lots of partying, drinking, and so on. And a lot of us at the British Museum think we should reinstitute that on Grand National Day, which is all going and winding the clock and having a party. But no one's taken us up on that yet, unfortunately. And that's the Mostyn Tompion. The next clock, we're running out of time, but is that all right if we carry on a bit more, Isabelle?
Yes, no, absolutely.
Okay. So if we turn around from that, I'm going to walk past this clock, which is the last one I'm going to look at, and past the ship. And over on the other side over here, we've got a clock which is related to the search for longitude. This picture is not in the British Museum, it's in the National Maritime Museum. Admiral Sir Cloudesley Shovel, I think one of the greatest names of an admiral, Cloudesley Shovel. And he sadly died when his ship was wrecked in 1707, when he was coming back from war against the French, when he couldn't tell where his longitude was. The only way of telling longitude at the time was called dead reckoning, where you had to measure the time and work out the time from the stars or the sun, and work out how far you traveled and try to plot it on a map. And if you got it wrong, things like this happened. You got wrecked on the Scilly Isles, and there's his ships being wrecked on the Scilly Isles. 4 ships were lost altogether, and 2,000 men were drowned. And this was such a disaster that Queen Anne, just before she died, passed the Longitude Act, which you can see here, offering a prize of £20,000 to anyone who could solve the problem of longitude. And the man who eventually solved it was this chap, John Harrison. And this picture is in the National Maritime Museum, as Isabelle said, one of the other places where I lecture. And the clocks that Harrison invented for it are also in the Maritime Museum. This is his first attempt, and those are his other attempts. And eventually, he produced a clock in 1770, which was copied by another person and taken on Captain Cook's voyage. And to get the prize, you had to invent a clock that kept accurate time at sea that could be copied by somebody else. It's no good if you were the only one who could make them. And that's how he won the £20,000. But in the meantime, Thomas Mudge was trying another method. There are lots of different methods for measuring longitude. And one was using the moon. And this is the clock he produced in 1754, trying to work out the moon methods. You can't quite see the dials here, but one of them has a measurement that goes up to 29.5 days. If you remember, I said the moon travels like that. And he also invented the detached lever escapement, which was used in all modern wristwatches right up until the invention of the quartz watch. And his clock was so accurate, it remained accurate to 0.2 of a second every 29.5 days. Probably one of the most accurate clocks ever invented. And this is the interior of his clock.
Bill, there is a comment from Kathy who says that the clocks are works of art, but also functional. Was the accuracy of the timekeeping secondary to the beauty of the clock, which obviously has terrible consequences if it's the case?
In different cases, yes. The Mostyn Tompion and this clock, it was the accuracy of the clock which was the most important thing. With the ship that I looked at, the clock wasn't very accurate, and it was just the beauty of the craftsmanship, the artwork. So there's a mixture of those in here. So that's the Mudge clock. Mm-hmm. There's a slightly more interesting, slightly better photograph. You can see the 29.5 on the dial here to show the phases of the moon. You can see the moon going across the top here. He was given £500 or 500 guineas to help him try to work out this method for longitude, and it probably would have worked, but he himself gave up and spent the rest of his life trying to improve on Harrison's clock. And it was Harrison's clock which actually became the modern chronometer, and was used by sailors right up until modern navigation techniques to work out where you are at sea or where you are in the world using longitude. But it's why, because it was all done in London, this is why Greenwich Mean Time is there, 0 degrees longitude is in Greenwich, and so on. Mudge did get some reward though. He was made Royal Watchmaker to the King and Queen and given a pension of £2,500 for his trouble. And the final clock I want to look at is turning your back on the Mudge. You can see the Tompion over there and the ship here. Right in the middle of the room, it's one of the most popular clocks in the museum, one that gets most people around it, and it's called the rolling ball clock. And it was invented by this man here, Sir William Congreve, who was a bit of an amateur inventor. He was best known at the time for inventing rockets. And these are some of his rockets. He used them after he'd seen them being used in India. Tipu Sultan, one of the Indian rulers who was fighting against the British in the 1780s and 90s, used these, and Congreve thought he could develop these even more, and he used them in the war against Napoleon when the British were fighting the French at Boulogne in 1805 and 1806. He even tried to use them in the Peninsular War. Wellington wasn't so keen on them, but also he developed rockets for fireworks and used them at the coronation of George IV in 1821. But as a sideline, he also, that's one of his rockets still surviving in the museum in Paris. He also had an idea that if you designed a clock and instead of using the pendulum, used a rocking board. You can see this board here, which rocks backwards and forwards with a ball rolling down it, that this could be an accurate way of keeping a clock regulated. And there he shows you the time on the clock. It doesn't, you can't do it for measuring minutes. This hand here, which is the minute hand on the right, whizzes round every 30 seconds from 30 to 60. Just whizzes all the way around. There you can see the rolling ball at the bottom. As you can see, this plate rolls to the left and to the right, and the ball, which you can see there, see here, runs up and down these grooves. And when after 30 seconds, it hits this spring, which knocks the board back the other way, and then it rolls all the way back the other way. And there it is in its wonderful dome. And it's probably the least accurate clock in the British Museum. It was a complete failure in terms of being able to produce a clock that tells accurate time. So again, answering, was it Kathy you asked about this? This is purely for show. It was nobody could ever use it for actual clock. This particular one, based on Congreve's rolling ball design, was made for the Royal Exchange, and it was put in the Royal Exchange as just as a spectacular thing to look at. This one was made in 1830 about, by an English maker called French, which I think is rather nice irony that Congreve spent a lot of his time fighting the French, and then you have an English maker called French actually made this wonderful clock, and it's in its original case and original dome, and it's quite a spectacular piece of glass blowing, being able to create that dome on top of it. And people stand for hours watching this go backwards and forwards. If you look on the internet, you can probably see lots of people's films on their mobile phone of this going backwards and forwards, because it's mesmerizing. Terrible clock, but wonderful piece. And occasionally these do come up for sale. The comic Bob Monkhouse owned one of these, and when he died a few years ago, it was sold by Sotheby's, I think, for £20,000. So they do come around just occasionally. But bad clock making. Okay, that's all I want to say about the clocks in the British Museum. I say we overrun the time a bit, but
thank you.
Happy to answer the questions.
Maybe we can stop the sharing of the screen and go
yes,
back
certainly.
to normal viewing.